Good morning, dear. Wish all of you are fine. Today we will correct our first partial exam. The first question. In the table given below, only one of the proposed answers, only one is correct. I have to write down the number of each question on my own paper and give with the justification. If you didn't justify your answer, then your grade will not be fully the answer corresponding to it. So I have to label the answer and justify why did I choose it. Number one, the simplified form of 4a squared over 9b cubed times 3b 4 over 2a cubed. As we know, when we are multiplying fractions, you can say that I have to multiply the numerators by each other and the denominators by each other. Or I can say that I have to simplify first. Here I have 4 and 2. I can divide both of them by 2. So 2 is kept above. The same 3 and 9. Here we said that we still have 2 above in the numerator. 3 and 9. I can simplify them. 3 divided by 3 is 1 and 9 divided by 3 is 3. So it's 2 over 3. What about a2, a3? I can simplify by a square. So a3, let's take out a times a, then a will be left. Similarly, b4 and b3 simplify by b cubed, then in the numerator we still have b. Then our answer will be 2b over 3a. Or simply by using my calculator, I can put the numbers and I'll get 2 over 3, and by simplification I have to know that the answer is 2b over 3a. Next one, 10 power 6 times 10 power 5 divided by 10 power 3. You can use your calculator, or you can say that 10 power 6 times 10 power 5 is 10 power 11. Since I have the same base multiplied by each other, I have to add the exponent. It's 6 plus 5, which is 11. Now we have 10 power 11 divided by 10 power 3. Since I have division, I have to subtract the exponent. The base will definitely be 10. What about the exponent? 11 minus 3 is 8. So the answer will be 10 power 8. Next one. If C equal 2 over 3 minus 3 over 2, then the opposite of C. Listen well, I have to find the opposite of C. But first, I have to solve C. Here we have 3 and 2 different denominators. I have to multiply here both numerator and denominator by 2. And in the second fraction, I have to multiply numerator and denominator by 3 to get the answer. It will be 6 over 9. It will be 4 over 6 minus 9 over 6. So the result will be minus 5 over 6. It's C. Now, what's the opposite of C? What's the opposite of minus 5 over 6? It's 5 over 6. Part 4, A equal minus 3 over 2 plus 3 over 5, and B is minus 3 over 2 times 3 over 5. To know if A is greater than B, less than or B, or equals to B, I have to solve A and B first. A should have the same denominator. Multiply the first fraction by 5. I mean the numerator and denominator. And in the second fraction, I have to multiply the numerator by denominator by 2 to get the denominator 10. Now, I know that A equal minus 9 over 10. In B, I have to multiply the fractions, and I know that the numerators should be multiplied by each other. So minus 3 times 3 is minus 9. And the denominators should be multiplied by each other. So 2 times 5 is 10. The answer of B is minus 9 over 10. Since they both have the same answer, then I can say that A equal B. Now, part 5. In the figure below, M is the midpoint of AB. and MN is parallel to AC, then by the converse of midpoint theorem, since MN is parallel to AC and M is the midpoint of AB, then definitely N is the midpoint of BC. Okay, it's just an application on the rule. Number 6, in the figure below, K midpoint of MN and L is midpoint of MP. So, by midpoint theorem, I can say that KL is parallel to NP and KL equal NP over 2. So, it's 4 over 2, which is 2 centimeter. It's direct application on the midpoint theorem. Now, number 2. Show that M and N are two opposite numbers. I have to solve M first, then N, and compare the results to see that they will be opposite. They told me to show. It means that M and N are definitely opposite numbers, but I have to show that they are opposite. M, 36 over 24, I can simplify by 6 or by 12 or by 4, it's up to you. But I have to keep simplifying until I get an irreducible fraction. 36 divided by 24 will be 3 over 2. If I use my calculator, the final answer will be shown directly. Now I have A2, A3, simplify by A2, then A will present in the denominator, and B5, B4 simplify by the lowest power by B4. So in the numerator, I still have B. The answer is 3B over 2A. And here we have square. I know that minus the square of a negative number is always positive. So 2A should be considered square, and also 3B. The result will be 2 square 4. A squared should be written. 3 squared is 9 and B squared should be written here. Okay, times. I know that when we multiply fractions, I have to multiply the numerators by each other and the denominators by each other. Minus 3 cube. Cube means I have an odd number of negative signs, so the answer should be negative. Or I can say minus times minus is minus. 3 cube is 27, B cube, 2 cube is 8, and this is A cube. Now it's turn to simplify. 4 over 8 is 1 over 2, 27 over 9 is 3. A square. A cube simplified by A squared, so A is kept in the denominator, and similarly B is kept in the numerator since the greatest power of B is in the numerator. And don't forget to write the negative sign. Since M is a 3B over 2A and N is minus 3B over 2A, the difference between them is just the negative sign, so I can say that M and N are opposite numbers. Okay, how can I get sure that they are opposite? I have to add them. M plus N equals 0, and I know that the sum of opposite numbers is 0. Part 3. Show that A and B are two reciprocal numbers. Reciprocal, it means that A equal 1 over B or B equal 1 over A. We write A, since we have subtraction and multiplication, I have to start with multiplication. So it's 1 minus 8 over 15 over 2 minus 1 times 2, 2, and 3 times 5, 15. So in the denominator, we should write 2 minus 2 over 15. Now the next step is to write using the same denominator. Here 1 is over 1, so I have to write it 15 over 15. And 15 minus 8 is 7. Similarly, 2 is 30 over 15. So 30 minus 2 is 28. Here we have 7 over 15 and 28 over 15. 15 should be cancelled, so the answer is 7 over 8. Simplify by 7, so it's 1 over 4. This is A. What about B? 2 over 3 minus 2 over 7. We don't have the same denominator, so I have to multiply the first fraction, both its numerator and denominator, by 7, and the second fraction I have to multiply by 3. Both numerator and denominator. It's always a rule. We either multiply both of them or we don't do anything at all. In the denominator, we have 2 over 3 times 1 over 7. Multiply the numerators by each other. 2 times 1, 2, and 3 times 7 is 21. Here is 8 over 2, which is 4. A equal 1 over 4 and B equal 4. So I can say that its product is 1. Then A and B are reciprocal numbers. Given the following fractions R, S, and T, by following PEMDAS rules, first I have to solve to show that R plus S equals 0. I have to solve each one alone. They should have the same denominator. So the answer of R is a 3 over 4. Once we have same denominator, I can add or subtract as required. This is R. What about S? Keep in your mind that you may solve it in a different way. It's okay if you reach the final answer. Okay? Think logically, right? Logically, and every way of calculation is accepted if you think logically. S equal. We have here subtraction and division and parentheses. By PEMDAS rule, I have to start with parentheses. We solve it first, then division becomes multiplication. We multiply by the inverse of the fraction. Here we have addition now, so I denominator and the final answer. Okay, the final answer here, we should have the same denominator. 13 over 9 over minus 1 over 9. The result will be minus 13. And you can use your calculator to check your answer. Minus 13 is an answer. Number 5, perform. Here you should know that we should have the same denominator. So wherever you have x and you want to reach 2x, I have to multiply both the numerator and denominator by 2. Then it will be 2 minus 3 minus 10 over 2x. So it's minus 11 over 2x. Okay, definitely the x is different from 0, so that the fraction is defined. Here we have 6y, 2y, 3y. The LCM is 6y, so I have to multiply 2 by 3 and 3 by 2 to get 6, since we have y in both fractions. The answer will be 1 plus 3 minus 2 all over 6y. It's 2 over 6y, simplify by 2, so it's 1 over 3y. What about G? Here, all of them are multiplied by each other. I can simplify by 7, simplify by 3, and simplify by 4. Minus times minus is a plus. We still have x times x times x, which is x cubed. Now, the last question. ABC is a triangle. M is symmetric of B with respect to A. In other words, A is the midpoint of MP. MA equal to AB. Okay, that's how I'm reading the given. N is symmetric of C with respect to A. N symmetric of C with respect to A. That means A is midpoint of NC and NA equal to AC. Reproduce the figure. It means that you have to draw the figure on your paper. We will complete it in the remaining parts. How to show that triangles ABC and AMN are congruent? As we said in the given, here you have MA equal to AB. Okay, this is the first one. NA equal to AC by symmetry. Here we have NAM angle or MAN, it's equal to BAC, vertically opposite angles, they make an X shape. So they are congruent by side, angle, side. List their homologous element. Here I said that MA equal to AB to prove they are congruent. These angles are vertically opposite angles, so definitely they are equal. And NA equal to AC. To look for homologous elements, what are the angles that we didn't mention yet? Here we have angle NMA equals to ABC and angle ANM equals to ACB. Okay, here we mentioned up till now 3 angles and 2 sides. What about the third side? Definitely by homologous element NM equal to BC. How to deduce that BC and MN are parallel? Here we have angle ACB, this angle here, equals to ANM. You see it? Or I can say that NMA equal to ABC. They are in the position of alternate interior angles. They are making the Z shape. In the position of alternate angles, and we proved them equal, then definitely I can conclude that NM is parallel to BC. Now, the parallel through A to BC, this is BC, the parallel drawn from A parallel to BC here, cuts MC at B. It means that I have to join M and C. They intersect at point B. How to prove that B is midpoint to MC? Listen, they told me the parallel through A. I mean, I can use AP is parallel to BC. I'm talking about a triangle here, NMC for example, or MBC. Both of them should be correct. If I take MBC, A is midpoint of MB and AP is parallel to BC, then by converse of midpoint theorem, P is midpoint of MC. Okay, that's it. You have to write the correction in your classwork copybook. Wish to you all fine. Goodbye.